Thank you all for showing up for my talk. I'm really excited about this, and hopefully you'll find this interesting and learn something new from it. A little bit about me. My name is Rishi Jain. I've come all the way from Bangalore, India. I'm fairly active on Twitter, and you can connect with me there. I work at Labs, and I'm a senior software engineer there. Labs is a remote-first company based out of Philadelphia. A few things about Labs that stand out as an employee are how smart my colleagues are, how empathetic and friendly all of them are, and how transparent the work culture is. It is a very diverse group of people coming from all kinds of backgrounds and countries. What do we do at Labs? Well, here's a nice summary of what all we do at Labs. Do reach out to us on Twitter at Labs or on our websites if you're interested in any of our services, or reach out to me and I'll connect you with the right folks. One of our offerings is tune reports for your Ruby applications. We've partnered with Nate Berkopek to do the tune reports, to work with him for the tune reports. Some of the information I'm going to share today is also from my experience of doing tune reports for the clients. I don't think Nate is in the audience. Yeah, he's not. That backfired. I was hoping he'll take up all the hard questions. So that's okay. Moving on. Well, a couple of ways we give back to the community are by writing blogs, and you can read our blogs on different topics at the link mentioned above. We also maintain a few open source gems, and you can check them out in the link as well. I'm going to share this presentation later on Twitter and on the Slack channel, so you can have access to this presentation. Well, RailsConf is very special for me for two reasons. First, I've been wanting to be part of this conference for a really long time, but it did not happen until this year. And for the second reason, I need to tell a small story. Back in 2019, I was speaking at RubyConf India, and my parents attended my talk. And then last year, my wife attended my talk at RubyConf India again, and she met all of my friends from the community, and it was fun. And at that stage, I joked, guess who will attend my talk from my family next time? And so it happens this time, I have my sister attend my talk. She's here from Chicago. So this makes the conference even more special for me. Well, during the course of this talk, if at any time you feel overwhelmed or lost, I just want to tell you that I've learned this stuff over time. I wanted to give this talk for junior developers specifically because I did not know most of these things when I was a junior developer. And I learned these things pretty late in my journey. So I hope this talk will help you learn these things far earlier in your journey than I did in mine. Well, let's get started with the reason why we all are here for. Let's do a quick poll with a show of hands. Raise your hands if you've heard or come across these things. Seen an N+1 query in your code base. All right, a lot of hands, happy to see. Heard from your customers that the app has been running slow for the past few days. All right, I see a few hands. Heard from your senior engineers or your DevOps team that the CPU utilization is very high or the app consumes a lot of memory. Have we deployed something new, or do we know why it could be happening? Right, few hands there, awesome. Well, congratulations. You've heard or been around things, all of which have to do with Rails performance monitoring. But this is not it. There are a lot of misconceptions about Rails performance, and let's talk about them as well. First, it is a senior dev thing. A lot of time it is assumed that anything around performance improvement and monitoring is an area for senior developers in the team. And as junior developers, our job is to build features that have been asked of us, and any issues found in the code should be caught in the code reviews by the senior devs. Well, I believe it should not be like this. First, as developers, we should understand the impact of the code we write from a performance perspective. Second, not everything can be caught in the code review by senior developers. Things will slip through. So it is our duty as junior devs to be more careful of what we write. During the course of this talk, we'll see how junior developers can identify these issues and help fix them, or be more aware of the impact of the code. Well, the backend front-end fiasco. Sometimes the engineers writing backend seem to assume that their code works perfectly and is fast. It is the issue of rendering, and thus it falls under the front-end team's bucket. After all, we are doing SQL queries and serializing the data. How can it be slow? It has to be fast. Meanwhile, the front-end team claims that they are just rendering whatever data the back-end team is sending, and it is their APIs that take so much of the time to send back the response. They need to check their back-end logs and what is making their API slow. I think this is really what is happening here. Yeah. Well, every time we hear something is slow, someone says, let's cache it. A classic mistake made often is assuming whatever is slow can be made fast by caching data. But there are times when it's not true. In fact, it can make things further slow. Maybe the data you're caching is changing too often, and now you have to invalidate the cache, load the cache again, and otherwise you might show stale data. And you might end up doing more network requests than what you were doing without caching. This is another common one. Bigger hardwares or more hardware will make your app fast. Well, not always. Think of it like this. Bigger highways will not make your cars any faster. Yes, it will accommodate more cars. It means more requests in our scenario, but it will not make those requests any faster. Now that we have seen some of the misconceptions around this, let's also look at why you should care about Rails performance monitoring at all. Well, I'll give you not one, but 4 reasons why you should care about it. They are scalability, user experience, cost savings, and professional growth. Let's look at each of them individually. Scalability. Consider this scenario. Your app has gone viral, and now you see the sudden influx of users coming to the app. As junior devs, you can proactively keep an eye on performance and address any issues that can help to ensure that the app is performing at increased traffic, thus making the app scalable. User experience. Imagine a sales cycle where your sales team is out there pitching the product, and there are 2 other sales teams pitching the competitor's product. All 3 of them have similar offerings and similar pricing. So it comes down to the user experience of the dashboards on offer. The user experience would be how simple it is to use the product and how fast the product responds. Does it take 5 seconds to do a transaction? Or does it take 300 milliseconds to do the same thing on a different app? Guess which one the client would prefer. If a web app is slow and unresponsive, users are likely to become frustrated and abandon the app altogether. By focusing on app performance, junior developers can help to ensure a positive user experience. Cost saving. Consider this. Your customers are complaining that they had to wait a long time before they see the response on their screen. And you think, yes, we need to add more servers to our stack to serve all our customers. Well, the issue could be due to increased request queuing time. Maybe it can be managed by changing the number of threads running, or maybe adding a new server. You can throw money at the problem without really understanding the root of the problem, and it can work in the short term, but you'll face the same problem again in the future for sure. So it is best to identify the reason for the problems and then optimize for the solution. We'll talk about request queuing further ahead in the presentation. And the last one, professional growth. As an engineer, it is very important to understand the implications of the code we write. Implications in user experience, cost to the company, consumption of resources. For example, what kind of code can lead to memory bloats in your app? It is good to know. Until we make effort to understand the impact of our code, we'll never be in a place to truly own the code we write, and it will make us better engineers. Having ownership can lead to better satisfaction in our jobs, higher salaries, and career advancements. Now that we have seen why Rails performance monitoring is important, let's break down the app into different components. In any typical system, you'll have a front end, a backend, a database, and a capacity. Let's start with the backend. When we talk about backend, the most important thing we need to know about is APM tools. Let's look at what is APM and what are APM tools. Application performance monitoring. It is the process of using software tools and telemetry data to monitor the performance of business-critical applications. These software tools are also called as APM tools. Let's look at some of the APM tools that you can use. New Relic, Datadog, Scout APM, and many more. These are not in any order of preference. It just happens to come to my mind when I think about APM tools, specifically used for Ruby on Rails applications. These tools can be scary to begin with. I can recall I was lost when I first logged into one of them, And I was like, there are so many options here, and I don't know where to go with them. So I wanted to give you a brief overview of what all these tools can do for us, so it makes it easier for you to get started. Let's look at some of the metrics these tools provide. Request queue, response time, top transactions, and many more. These are only a fraction of the metrics that these APM tools can give us access to. All of them provide insights about how your app is doing resource-wise, utilization-wise, capacity-wise, user experience-wise. Let's look at some of these metrics individually and what information they can provide us. Request queuing. It is one of my personal favorite one. It is basically a measure of how long your request has to wait before it gets picked up for processing by the app server. I'll say it again. It is the amount of time that a request must wait before being addressed. This is what a graph can actually look for a request queue. The request queue time should be between 20 to 50 milliseconds. Anything over that is a sign that something is not right and customers are not having the best experience. Let's look at the next slide for an example. Look at this graph. We see a spike in the request queue time up to 10,000 milliseconds, that is 10 seconds. Obviously, the user would be left frustrated if nothing happens for 10 seconds. The simple reason why request queue time shoots up is that all your existing servers are busy with processing other requests, and your request has to wait until a server is available to work on it. So it is directly related to resource allocation. If the request queue time is less than 20 milliseconds, it's constantly under 20 milliseconds, then it is an indication that maybe you are over-provisioned and you should look at reducing the resources. So when you're adding more servers, you're typically reducing the request queue time. APMs also give you the list of top slowest transactions for your web applications, the average, the P95, the P99 response time, and you can sort by throughput and some other parameters. This gives you a quick insight into which endpoints are critical, that is, receive the most traffic and which are slow. So you can fix the issues with those slow endpoints. You can even drill down further for more information about specific endpoint. You can get information around what all stages the request went through, how much time it spent in each step. And you can also get metrics around what queries were fired and how much time each query took. So if there's a query that is slow, you can debug that specific query, making that endpoint faster than before. It also gives you data about throughput. It shows you when your customer typically accesses your application. So for instance, if you're planning any system upgrades or major deployments, it would be a good idea to do that when you receive less traffic on your application. It also gives you insight about object allocations. It is very easy in Ruby to not pay attention to the amount of objects we are creating, and typically it should not cross 50,000 live objects at any time. Higher than this can lead to slowdowns in the system that will lead to higher memory consumption. Let's look at a very common pattern in Rails applications. Look at this code. We are fetching all the products and looping through them to update an attribute. It looks pretty straightforward. But there's a problem. The problem lies in product.all. It will load all the product at once in memory. It will shoot up the memory usage of your application and thus affecting your application. How to fix this though? The solution is not to load all the products at once. Instead, use the findEach method to load them in batches and does not create objects without even realizing it. It is suggested to use the findEach method even when you have just started the application. That means you do not have enough data at the moment, so using all or findEach will not make any difference. But if you start with this approach, you'll not be dealing with memory issues when the database grows. This is another metric which is important. This directly gives you information about your instance restarts. Let's look at the next slide for a weird example. When you see that specific time in the middle of the graph where so many lines are crisscrossed, that is when so many of the instances restarted at a very specific time of the day. It is critical information to try and debug, like what happened during that time. You can look at memory, CPU utilization, throughput, request queue, or something that helps you draw an inference of what went down at that time. If you have a theory of what went wrong, APM with its data also helps you verify your theory and back it up. In most cases, almost all, when you have a theory but the data is not verifying it, the theory is most likely wrong. Now that we have seen what an APM is, how it can help us with different metrics it provides, let's look at some of the very common mistakes found in Rails application. The first one, n+1 query. Let's look at this query. What we're doing is we're finding all the posts and then printing the post title and the user's username. If you look at the logs, it says this DB had 6 posts, so it fired 7 queries, a query to fetch all the posts and 6 other queries to fetch their individual users' information. This is okay for a small DB, but imagine this happening when it has 10,000 posts, so it would fire so many queries and then response of the API would be slow. The fix is pretty simple. We need to eager load the user info, and now it just fires 2 queries. It won't matter if it is 6 posts or 10,000 posts. As simple as this is, we find n+1 queries all the time in Rails application that we work on for tuned reports that we do at OnView Labs. Now these are simple n+1s, which are also easy to fix. Let's look at some of the weird ones. Consider this view code. We're looping through the post and then rendering different partials based on a condition. Look at this line of the code which says post.lots_of_comments. We're calling this method for each post in the collection. Let's understand how this method is defined. This can seem alright at first glance since we must have eager loaded the comments because now we know. Only the problem is with the count method. It fires a database query to calculate the count. So even though the comments are eager loaded, it will still fire a query every time for each post in the collection, as we're calling this for each post in the iteration. The easy way to fix this is replacing count with size. The way size works, it will not fire the database query to calculate the size. Small fix, but very easy to make this mistake, which can make your API really slow. Look at this method. We are trying to find the first famous comment for the post. A famous comment is when it is liked by more than 5 people. Now that we know of preloading the data, we can preload the comments for a post. There should not be any extra queries. Unfortunately not. The problem is that the where clause does not really work with preloaded data. It would still go ahead and fire a fresh query every single time this is called. How to fix this though? The first way, the Ruby way. We can preload all the comments and use the enumerables to do the manipulation for us. In this case, we can use the find method to find the most famous first comment. This way we do not touch the database at all. But what if we had like lots of comments for each post? Would it still make sense to do the processing on Ruby? Because we'll be storing all these objects in memory after all, and fixing memory issues are hard. Here's a second way. We can create an association with the conditions that we want. In this case, liked by people greater than 5. And then preload the association while loading the posts. This could be the most optimized way of doing this. Now we know what a menace n+1 query can be. It is important to know how to find them. The first way is the APM. APMs will give you some information about the queries which are being fired. It will show you the query that was fired, it will show you how many times it is fired, and some more information about the queries, but APMs do not track everything. The second way is to use the Rack Mini Profiler gem. We're going to talk about it further ahead, but it does help us in profiling the performance of any page, and we can see all the n+1 being fired. This is the second common mistake found in Rails applications again and again, lack of background jobs. Imagine this code. The generate invoice and notify method will generate the invoice for the customer and send the notification to the customer at 3 different places. It will send an SMS, an email, and a WhatsApp message. It will use a third-party service to send the SMS. It will use SES to send an email, and it will also use some third party to send WhatsApp messages. All of this will happen while the customer will wait for the response on the screen. This is not the most optimal user experience. We should utilize background jobs here. All the notifications can be sent via a background job so that the customer does not wait on the screen for a response. And as a response, the app can show a message saying, hey, you'll receive an invoice in your email. But time and again, I've seen this pattern in different Rails applications where some processing that can happen in the background is still being done on the main request. This is a third one, timeouts for third party. Consider the previous example. Imagine we were using some third-party service to send SMS notification to our customers. What if the SMS vendor is having their own issues with the system and the request, which usually sends back the response in 200 milliseconds, is now timing out after a default wait of 60 seconds? That means our request will wait for 60 seconds to get the response back from the vendor, and then we'll take some action based on that. we should be stricter with the timeouts that we have, especially when we are dependent on a third party, and not leave everything for default. Ideally, wait for 2 seconds. But if we don't get the response in 2 seconds, handle that case explicitly. Maybe push a job that will retry this later. Maybe store an exception somewhere. But never wait for any vendor if they're taking more than 2 seconds to come back with a response. It is always a good idea to stay in control of how long a request should wait for its response. Another common one. I've seen this happen in so many Rails applications, and it is very easy to forget about the database indexes. Consider this table. It has 2 columns of our interest, name and email. Look at this query. We do a simple query to find the first user with a certain email. In our APMs, we've been seeing the query slow. So let's analyze it further. So we run the explain command on the query. It will give us the query plan for which it will tell us how the database is going to execute this query. Notice that it says SEQ scan towards the end of the screenshot, which basically means sequential scan over the whole table. That is, it will scan each row in the table and match the email. That is going to be very slow. Larger the table, the more time it will take. Also notice the cost. The total cost is 2440. Now, the next step to make this query faster would be to add an index on the table on the email column and then measure the change. Let's run the explain on it again, and now notice the change in the query plan. It does not say sequential scan anymore. It says index scan using an index. Look at the cost, 8.44. It has come down from 2440 to 8.44. That is massive gain. Missing indexes is such a common pattern in a lot of Rails application code. Let's look at this query to understand another critical thing about indexes. We have added 2 indexes to this table. There's a slow index and there's a fast index. Let's look at how each perform. Right now, we don't know what those indexes are. We know one is slow and one is fast. We'll see later what those slow and fast indexes were. Look at this graph. The fast index runs in 0.029 seconds, and the slow one runs in 0.055 seconds. If you look at the time difference between slow and the fast query, it is considerable. Fast is almost twice as fast as the slow one. Still, both are quite fast in the real world because 0.055 seconds is not slow at all. But what happens when the data volume grows? As the data volume is growing, the time taken by both the indexes to run the query is also growing. Notice at max capacity of data volume, the fast one is almost doubled, but the slow one has almost gone 20x. Now the difference between them is too big to ignore. Let's look at how a query is formed with each of these indexes. This is the plan for the query with slow index. If you pay attention to the last 2 lines there, it says access predicate on section field and then filtering based on the results it got from above, which basically means it is filtering on ID 2 based on the result it got from access. This is the plan for the query with faster index. If you pay attention to the last line, it has access predicate on section and ID2 combined. So it would be useful to know what were these slow and fast indexes. This is for the slow index. The index was defined on section, ID1 and ID2. And the query was done on section and ID2. If you recall the query plan for slow index, the access was done only for section while ID2 was filtered out. The order of how you define the index is very important. Here, because it was expecting an ID1 field to be present before ID2 in the query, and it was not, so index could not be applied for both. Let's look at the fast index now. Oops, sorry. Okay. Yeah. Here, the order is changed. Because ID2 is second in order, the query applies the composite index of section and ID2 combined and makes the query faster. Now that we have seen some of the common mistakes in Rails application, let's also look at some of the practices that can hurt the performance of your Rails application. Lack of pluck. This is such a common pattern. You want to find and collect all the values of a specific column in an array. You end up using map for it. Using pluck is much faster than using map. Let's look at the benchmarking data. We can see the difference between the 2 approaches when done over 1 million records in the table and around 10,000 records matching the where clause. We can see the pluck is so much faster than the map and also consumes a lot less memory. It is a very common ask to get the number of records present in a table. Generally, developers have been using length, count, and size without really understanding the differences in them. Length will always load all the records in the memory and then calculate the number of objects. Count will always go to the database to find the number of records even if the collection is already loaded. Size is the most optimized one. It goes to the DB if the collection is not loaded, and if it is already loaded in the memory, then it would count the number of records from there. Looking at the data, we can see that the size and the count took roughly the same time when it went to the DB, but size took way less time when the records were already loaded. Another very common ask is to check if the records even exist or not. Generally, developers have been using these methods as they like to, but similar to length, count, and size, it also has slight differences in how they work. Exist will trigger a DB query even if records are loaded into the memory. Present or blank, this will load the objects in the memory, so use these methods only if you want to reuse the objects later. Any or none, they are the best of both worlds. If the records are already loaded, then it does the counting on the loaded records, and if not, then it goes to the DB to load the records and then does the counting. Create bulk data. This is another trivial use case when we have to create a bunch of records in bulk. We end up looping through each object, creating one at a time. This is fine if the number of records are small, like under a dozen. But if it is more than that, much higher than that, then it can really affect the performance of the method. One option is to use the insert all method. It comes with its own set of problems, but if you're able to navigate those problems, then it's worth the performance gain. Let's look at this code. Here we want to get the users whose age is 51 and their name starts with A, and we want 10 such results. As we can see in the code, we're doing where clause for fetching all the users with age 51 and then filtering those results with Ruby code. There are instances when doing the filtering on Ruby would be preferred way of doing it as it is easier to do it, but it may not be the best approach when it comes to performance. It might be better to do this on the SQL side rather than let Ruby doing it. As we can see this from the data, for a large set of data, the SQL outperforms Ruby by a great margin. We can choose to do Ruby when we know that the records are not a lot and will also not grow in the future. In performance, the most important thing is benchmarking. If you think making a change will make your app faster, prove it. And the only way to prove something is to measure the before and after metrics of the changes and check the results. And to do just that, there are a few gems that we can use. I'm only going to talk about one of them, but there are a few options out there. This is the gem I'm going to talk about, benchmark IPS. Some of you may already know that benchmark is a module which is part of Ruby. And then there's a gem called benchmark IPS. There is some differences in both of them and how they work, but we'll be only looking at the gem for now. Benchmark IPS will report the number of iterations per second for a given block of code. It uses standard deviation, which is the concept of statistics, to analyze the result. A high standard deviation could indicate the results having as too much variability. Let's look at an example. Let's take a few seconds to look at this code. Consider that we have 3 different ways to loop this, and we are going to benchmark which is the best approach of the 3. Let's look at the results, what we get from when we run this code. It tells us how each of the code blocks did in iterations per second, and it also indicates the standard deviation margin at the end of each result. Another example with some real differences in them. There's a slow method and there's a fast method. The slow method is being looped 100 times, while the fast one will run just once. Let's look at the results when we run the benchmark code. We can see their iterations per second and their deviations as well. Here, since the difference between the 2 methods is huge, the deviation does not really matter. But when the difference between the benchmarked entities is not big, the deviation does matter. From now on, when someone gives you a number, politely ask for the error. I like this message from Richard as it gives me an additional way of looking at data. This is from his blog on statistical literacy. Now we have seen how to benchmark our code, but you'll also need another tool in your arsenal, and that is for profiling, to figure out what is going on and where does it happen in your code. After you set up the gem and run the app, this is what you'll start seeing. This icon in the top left corner of your screen. It is customizable though, where do you want to place this icon. Once you click on it, it opens a pop-up with a lot of information. It shows you the request, what all steps it went through, and what was the time taken for each step. It even shows you the SQL queries fired during those events. If you click on that SQL link, it shows you what query was fired and which line triggered it. It is very helpful when you're trying to debug slow queries. Sometimes finding what really triggered the query could be hard though. And for that reason, there's an option to see the full backtrace and not just one line in the code. The option is called full backtrace. You can pass this as a query parameter. Can I get a volunteer to please read the logs for us? All right, no, I'm kidding. Do not try to read the logs. I just wanted to give you an example to show you that it gives you a lot of information to look at when you use that option. It also gives you option to get more information about the page load events and how much time it spent in each of them. While these are only a handful of features that we saw, there's a lot more this gem can do. It can help us analyze memory, profile garbage collection, loads flame graphs. It also helps us choose which users we want to load the Rack Mini Profiler icon for, as we would not want our customers to start profiling the code for us after all. Well, now that we have seen what APM is, what kind of information it tells us about our backend, and how we can avoid some of the common mistakes, it's time we go and look at some of the front-end stuff. Why though? Why are we talking about front-end? Well, this is what your customer sees. They don't see the API, they don't see the Puma threads. They care about their experience is when they use your product. This is the highest level of metric we can measure, and most high-level metrics consist of various mid and small-level metrics. Most people end up ignoring the high-level metrics and are too focused on small-level metrics like request queue and response time. While those are important, but it means nothing if the user experience is not improved. This is what a typical page load can look like. We do a lookup for the address of the domain name, then we typically open a SSL connection, a TCP request, then the request to your Rails server, and then we start getting back the response from the Rails server in TCP, and then we load the JS, the CSS, and then we execute them. Some of these steps are async, some are sync. Some we have control over and some we don't. So what are some of the metrics that we can use to measure these steps? Well, these are some of the metrics we can use to measure the performance of the web app. The list is long and is not standard. Everyone is doing their own thing. All kind of tools will give you all kind of metrics that are hard to understand. And when you change the tools, the metrics are different. To solve this problem and to simplify the landscape, Google came up with Core Web Vitals. In 2021, Google came with a set of Core Web Vital metrics. The aim was simple, to simplify the landscape and help sites focus on the metrics that matter the most. The three metrics are largest contentful paint, first input delay, and cumulative layout shift. These metrics also have weight in Google ranking for your website. So better the values of these metrics, the better the ranking of your website. We'll talk about one of them and we'll see where we are. If we have time, we'll go to the next ones as well. Well, largest contentful paint. It is the time taken for the largest image or the text block to be loaded on the website. It is also called as the time taken for the main content of the page to load. It is a measure of page speed, as there are other metrics like FCP, first contentful paint, which only talk about the first pixel loaded on the site, or something like DOM content loaded, which is not user-centric. So LCP is all about how does the user sees your website and how it interacts with it. If you observe here, the timeline of the request begins from the left side of the graph. The request starts with loading the HTML document, which is shown in the blue color. Then it moves to load the style sheets, and then it moves to load the LCP resource, and then to some other scripts. Let's break this down further in blocks to truly understand each step in this sequence of events. The first block is called time to first byte. This would typically include the DNS lookup, the SSL connection, TCP, Rails response, and then getting the first byte from the server in the form of HTML document. After this, the second block is called the resource load delay. It is loading the style sheets here. The third block is called the resource load time. That is where the main content or the LCP happens. And then at the end is the render element delay. Because this is a timeline of the time spent by the browser for each block, it all adds up for the user experience. For example, if the time to first byte takes up 10 seconds, that means the user is not going to see anything on the website for at least 10 seconds. but we don't know how much time it should typically spend on each of these components. Let's look at what are the acceptable values for a good LCP. If your website is having LCP greater than 2.5 seconds, it is an area of improvement. Anything beyond 4 seconds is bad, and you should definitely fix that. And anything under 2.5 is considered good. You might be thinking about what affects the loading of the LCP and how you can optimize it. Well, we'll look at that. But before that, let's look at how to even measure the LCP. Well, there are two types of tools at our disposal: field tools and lab tools. Field tools are real-time monitoring tools. These are generally paid tools. And then there are lab tools, which are also called as synthetic tools, as they are simulation-based and their values are approximate values, but close to reality. Let's look at the lab tools, as some of them are free to use and are a good starting point. Here are a few lab tools. Google Lighthouse and Web Vitals Chrome extension are a free tool that you can use to get a lot of metrics. I think Lighthouse tool is a good starting point. If you use the Lighthouse tool, it lets you simulate the user experience and then gives you information about how your site is doing performance, SEO, accessibility wise, and more. This is what the performance tab can look like. It gives you an overall score and then some matrix which affects this score. One of them is LCP. If you click on the LCP tab on it, it shows you what the largest contentful paint was, as in which element of the page. And it also gives you a report on how to improve the LCP and other metrics. Now that we know what is LCP, what are the good values, and how to measure them, we can talk about what makes the LCP slow. What makes it slow? There are three very important reasons for slow LCP: slow server response time, render blocking JS and CSS, and slow resource load times. Let's look at them individually. All right, I forgot about this. No problem. Well, this one is a straightforward one. It's hard to make any app faster if the response from the backend server is slow. You could have a blazing fast UI, but if the backend server does not respond fast enough, there is nothing the UI can do. The slow response from the server could be due to unoptimized queries, under-provisioned servers, and so many other things that can lead to it. Make the response from the backend fast, and then there's scope to do other improvements. I'll move quickly before somebody clicks a picture. The next one is render blocking JS and CSS. If you have put a bunch of JS and CSS in the head section of the page, everything else will have to wait until those are loaded. Imagine you have a large JS file that you have downloaded and the browser is ready with the LCP, but it will not render it because the main thread of the browser is still working on executing the large JS file. For instance, the JS you're loading might be a third-party JS and there's delay from the third party. So now you have no control over when something loads, and the main thread will wait for it to complete, and then the LCP can be rendered. If you look at this graph, in the middle of it says LCP resource in green and then large style sheet in purple. If you look closely, both are starting at the same time and the LCP is downloaded and then it is ready to be rendered, but it will wait for the style sheet to be loaded fully and then the LCP will be rendered. So in this case, the CSS file was blocking the rendering of the LCP element. This is another reason for bad LCP, slow resource times. If you look at the purple line which says first resource and then observe when the green line begins, there's a considerable timeline between them. This is an indication of area of improvement. Ideally, the purple line and the green line should start at the same time. Let's look at how to fix some of these issues and improve the LCP. Look at this graph again. The whole area marked as opportunity to improve. This is when the LCP waits for the resources to load and the browser starts loading the LCP. But the interesting bit here is what affects when LCP will actually start to load. There are two main things that affect the loading of LCP. First, it all comes down to when the resource is found by the browser's preload scanner. And second, what is the priority defined for that element by you? One of the reasons why content takes so much time to start loading is that the priority is never defined. If we know something that needs to be loaded as early as possible, use this knowledge, use the priority. What are some of the scenarios when the browser does not find the LCP early? Maybe you are adding an image tag via JS and it will only be added when the JS is executed and the event is triggered. So it cannot be loaded as earliest as it depends on something else now. Maybe you have an LCP element that requires a background image from CSS. Then it will only be loaded after the CSS is loaded and executed. Or maybe you're updating the source attribute with some lazily loaded JS library, and now it will load the element from the source when the event is triggered. All of these elements are not found during the browser's preload scan and thus tend to be loaded last. The trick is to avoid such scenarios for your elements that you want to load as early as possible. Some more reasons that can lead to delay in when the resource is found. If you have explicitly set the loading to be lazy for the element, then it will not load them on priority. Avoid using this for LCP elements. CDNs. While CDNs are a great way to reduce the resource load time, using a CDN will additionally cost a connection to a third party. That being said, many CDNs provide a way to proxy these requests via your origin, so use that if possible. As far as the priority of the element is considered, images are not initially loaded with the highest priority as they are not the render blocking resources. But you can tell the browser to load an image with high priority and some with less priority. After all these changes are done, the previous representation with the opportunity to improve, that area between the first resource and the LCP resource should change to this. You should ideally see the LCP starts to load as the first resource also starts to load. Let's look at this again. The problem here is that our LCP is ready to render, but it is blocked by some CSS resource that need to be rendered first, and then our LCP can be rendered. Let's look at how you can get rid of this. First way is inline the CSS. There are a couple of ways we can do, but first one is this. You can inline the CSS into the HTML, but you need to be careful here as you should inline when the CSS is small. If the CSS file is itself large, inlining it might make the performance of the app even worse, as inlined content cannot benefit from caching in subsequent pages. And the second, and I think the best way to do it, is reducing the unused CSS. It is always a good idea to get rid of the CSS that you don't need, making the file smaller. The less data to load, the faster your app will be. Defer CSS. Split your style sheet and defer all parts of the CSS that can be loaded lazily. There are times when parts of the CSS are not needed immediately and can be loaded lazily. And minify CSS. This is again in line with the reducing the size. The smaller the size, the faster to load it will be. And it is not only the CSS which can be render blocking, JS can also be render blocking. It will almost always lead to negative performance when we don't use the async or defer property for JS that can be loaded lazily. You could be using some third-party plugins that need not be needed to load with the page and can be loaded lazily, but we end up using on the main request. And just like CSS, we can inline the JS as well. But the same thing, we need to make sure that the JS is small. There are some other ways as well to improve the LCP. Using modern image formats. WebP have superior compression and quality characteristics, so they will load faster and consume less data. Another way is to compress images, and you can do that by using CDNs or by serving correct image sizes to the server. Using a CDN, it reduces the distance the resource has to travel. For images, it's even better because it already applies a lot of these techniques by default. And the last one is reducing the time to first byte. We looked at it earlier, what makes up the TTP, and one way of improving or reducing the TTP is to improve the backend response. I want to call out here a website called web.dev. It is a great resource to learn more about this in general, and if you find this interesting, go and check that website later. The next core web vital is first input delay. I don't have a lot of time left, so I'm going to skip this, but a lot of these techniques also improves the FID and also improves the cumulative layout shift, but I'm not going to talk about them due to lack of time. I want to talk about this, resources. If you find this topic interesting, here are some of the resources you can use to learn things in detail. For example, the first one is Nate Berkopek's performance workshop and all of his material. They are a great starting point for Rails performance. Web.dev, I already spoke about it. There's a book called SQL Performance Explained, which is also like a good book to learn more about databases. And then a link of 3 different blogs, like they're great blogs, and I have shamelessly picked up content from them, screenshots, benchmarking data, because it directly correlated with my talk. And they're great, and I wanted to give them a shout out here so you can check them out later. Yeah, that's my talk. Thank you for attending the talk. And I hope you learned something new today. That's also my Twitter handle and the company I work for. So if you have any questions or want to discuss any projects with us, feel free to reach out to me in person or online on any of those Twitter handles or on our websites. Thank you.